Engenius 4x4x4 ECW536S. I've had this for a while. Actually, it's a funny story. When FedEx brought this, it came in a Ziploc bag because they destroyed the box. I almost didn't get it, and I got an early one, and then it was bad. Then there was a firmware update, and the firmware update fixed things. I've been working on this for a few months, but it also gave me an itch that I had to scratch that turned into an RF chamber, and now I have basement cat. It's going to be a good review. Just hang in there with me, just for a second. Okay, so this is the Engenius Cloud 7 4x4x4 ECW536S. This is a big, honkin', heavy, feels like you could knock somebody out with it, access point. Wi-Fi 7, MLO, multi-link operation. I'll spoil it for you. Yes, multi-link operation works. It's designed as a companion for these, the Cloud 7 2x2x2. So you have this, but then you have a bunch of these scattered around. Now I've already reviewed the 2x2x2, but the critical piece that was coming, that was kind of missing, is the 4x4x4, because it's not just about density, it's also about power users and unpacking that and doing all that sort of stuff. 10 gigabit, it has 10 gigabit PoE and a second LAN port, which is also 10 gigabit. Optional 12 volt DC input and a Kensington lock port and a fairly elaborate mounting system. It comes with stuff to mount on the pole or the ceiling, or just the standard stuff that you would expect. When you get one of these, you can download the app on your phone, scan the QR code, and set it up. These are cloud managed, Cloud 7, as the name might imply. The devices do actually have a lot of intelligence, and they just move configuration files around. So if you spy on your network and you look at the traffic, it is reassuring. It's much more reassuring than, say, when you're looking at the network traffic for something like Juniper. There's a lot of cloud activity there. There's a lot of even like the Netgear. We just reviewed the Netgear and we did the security audit. It's got the Amazon IoT gateway stuff on it. Those are insanely chatty access points. These are cloud managed. They're kind of like Wifi with how they work with the cloud management app. There is a version, I think there is a version of these that are not cloud managed. Those are the ones that I bought for myself at home that are basically the same hardware, but it's the Wi-Fi 6 version instead of Wi-Fi 7. The performance is really good. But these are cloud managed, so be aware of that. Let's get into the review, because there's some interesting stuff. Now, the first thing that I mentioned, Wi-Fi 7 is weird. And you just have to get read in on Wi-Fi 7 to understand how weird it is, because there's a lot of optional stuff in the specifications. And as I have always said, optional specifications are where marketing goes to party. And it's so bad that Wi-Fi 7, Y-Fi 7, and Wi-Fi 7 certified are all entirely different things. Wi-Fi 7 certified would actually show up on the Wi-Fi 7 website and tell you what features that you have, but almost nothing has that, or the things that do have that are actually at the lower end. These are really meant for commercial installations, campus installations. They're not meant for home installation unless you have a giant home or a whole bunch of devices. But these devices, IMHO, are surprisingly affordable for the level of performance that they offer. And I like having these plus those for IoT networks and that sort of stuff. But then, we're talking 2.4, 5, and 6 gigahertz with Wi-Fi 7 and 320 megahertz channel width. So just basic throughput tests, and we pitted this against the Netgear, the Netgear Nighthawk and Asus BE2000, just to see how it would do. Now, throughput results. I've got a throughput results table here. We tested both TCP and UDP, client server, server client. Which way is the traffic flowing between the two of them? And what I wanted to do here was confirm that I could see packets on both frequencies with the packet capture, 5 and 6 gigahertz versus 6 gigahertz alone. And if you look at it, you notice it's pretty close. TCP client server, 3.1 gigabit versus 3.07 gigabit for 6 gigahertz only. 5 gigahertz really isn't doing a lot for us. And if you look at the packet capture, it was switching really quickly between 5 and 6 gigahertz. I would say low latency, zero latency, because you had a little bit of overlap where both frequencies were sending or receiving packets. Now that may have been a buffer draining or something like that, but you really did have MLO operation. True MLO operation, maybe both links are sending and receiving data at the same time with significant overlap, like both channels are busy at the same time. that's not really what was happening here, except for the tail end and the beginning of those conversations, which again may have just been a buffer emptying or something like that. But it does give us some pretty good results in terms of raw throughput. 3 gigabit. That's awesome. The other nice thing at 6 gigahertz is not a lot of devices use 6 gigahertz. So if you have line of sight, as we did in our RF chamber, you'll be able to have a nice clean 6 gigahertz link, and it'll run really insanely fast. The deal with Wi-Fi 7 is that it's all about density, and density means that you need a lot of access points. And it also helps if it's line of sight. So like if you have a laptop like this and your access point is on the ceiling and there's not a lot between you and there, it's going to work great. By the way, the test chamber here is really interesting. I mentioned basement cat earlier. Yes, there's a cat in the basement. This is basically an RF chamber. It's metal in the foundation and the walls and the ceiling, and it's grounded. And your cell phone doesn't work in there, and the Wi-Fi doesn't work in there. But it makes a great testing chamber for wireless. And then inside that is Steve's old sound chamber. So the next table is a 3-way comparison. The full review is on the forum. You should check that out. I'm having trouble deciding on what the format is, because sometimes I just want to ramble and tell you about my adventures, and then people complain. And then sometimes it's like, let's go through this very boring and dry presentation about performance, and people complain. So I'm letting you know, for probably the 5th time, there's a full review on the forum. You can just go read it. You should engage below with a comment, though, to, say hello and let me know what you think, or if I did well, give me a cookie. I don't know. So in a three-way comparison, there's something really interesting that happened versus the Netgear RS700S. It is not MLO. It can't do 2 radios at the same time. It's 3 frequencies, but it's definitely only 1 frequency in use at the same time, and it takes a little bit to switch frequencies. However, we're 2 TCP streams from a single client, 3.5 gigabit. That is our best score in all of our testing. Very surprising, too, because Netgear seems to just focus on the one band and get it done. However, latency, the latency is half in the unloaded scenarios. 6.7 milliseconds versus 12.6 milliseconds. Once everything is really heavily loaded, it's about the same, like 20, 25, 30 milliseconds. The Asus comes out on top here with everything fully under load, 19 milliseconds to 12 milliseconds. But the Asus is reserving bandwidth. The Asus will not let you use all of the channel bandwidth because it wants to keep the latency low. But the Engenius, I think, does it the correct way so that you can use all of the bandwidth, but it doesn't make the latency absurdly worse. The difference between 6 and 30 milliseconds for an unloaded versus a loaded link when we're talking about this kind of radio is pretty good. And before you say, oh, it's all sunshine and rainbows for Asus, no, the reverse latency, when you're uploading, like you're sending traffic from a laptop out on the internet, the Asus is weirdly limited to 300 megabit, whereas, we're doing many gigabits. So the next thing I want to do is test latency under some different configurations. And this test protocol might change as I kind of explore here, but basically, let's talk about latency and latency spikes, and like something might happen on the network. Maybe somebody goes to download a movie. Well, downloading a movie, that should stream. That really shouldn't be that bad. Maybe somebody fires up Steam, somebody else's computer, and then they start downloading something really quickly, and then that's going to create a loaded link. What sort of bad things will happen? Basically nothing, because you can have multiple 3 gigabit streams active at any given time, which is a bit of a challenge to test that scenario when you could have 2 or 3 clients that are all using 3.5 gigabit of bandwidth each. We're not congesting the wired connection even with that. We've still got a little bit more room for data at 10 gigabit with 3 links running at 3.5 gigabit, which is awesome, but also makes it sort of a pain to test. For MMOs or MOBAs, the difference between a wired connection and a wireless connection, if it's only making a difference of like 20 or 30 milliseconds, you're probably not going to notice. MOBAs don't use a lot of bandwidth either, so most of the time your connection is going to be at that 6 millisecond range. So your latency really is bouncing between 6 or 7 milliseconds and that like 20 milliseconds if the link is starting to get kind of congested. And that's for the link being basically full, which is not happening when you just have one other person downloading at 3 gigabit. Your latency will go from 6 or 7 milliseconds to like 11 or 12. That's what we're doing in the testing here, which is not always, I mean, it depends on the router, but the Engenius is doing it really well until it gets fully loaded, and then your latency will go up, and worst case scenario it's like 30 milliseconds, but it's still a really good result. So I wanted to test the Engenius on MLO and 6G, and then you've got the Asus for comparison, since it did pretty well out of the three of them. And you can kind of see there, if you limit the Engenius to just 6 gigahertz, and you've got one link that is fully saturating everything, boom, your latency 70 milliseconds. That's not fabulous. And you would notice, I think, a latency spike from 6 to 70 milliseconds. But normal operation with a good client like the BE211 and multi-link operation, 22.8 milliseconds. Much, much better. This is why it drives me insane that there's optional features here. It's like, I'm an enthusiast and I can't run a wire to my gaming computer. I have to have wireless because whatever reason. And the optional features will make a huge difference in your quality of life in a lot of relatively common scenarios where there's a bunch of people on your Wi-Fi doing stuff and you can't really control that. This also maybe gives you some ideas for data that you can capture in your own network as we work on these videos. I mean, I've done a lot of other videos on other hardware. You can check that out, and maybe with all of that, you sort of get a clue for how these things are working. Or if you troubleshoot wireless in a corporate network, one executive is like losing their mind because something happens. There's even tools in even higher end access points to give you a lot of insight to devices even before they join the network. And you can get telemetry like that from SNMP and other stuff in the Engenius app, which is really cool. But I'm just testing the connection for now. We'll talk more about the app and the configuration there in a bit. So just for reference, I've also got the load sweep for the Engenius in a couple different configurations, and then the Asus for comparison. And you can look at that if you have any questions, engage below or in the forum, but I think it's pretty self-explanatory. I also have a table for the MLO decoding. So multi-link operation, it's hard to lie about that because the protocol exchange is not encrypted. You can look at it with packet capture and you can see exactly what the device advertises. It's not the specs, but you can look at the packet capture and there's no arguing with it. You're not going to get an email from a rep at the company that's like, well, actually, it's not really like, because it's not in the packet. If it's not in the packet, if it's not in the exchange, there's no ambiguity. And so here's this table, which is really useful for explaining that. So bottom line, for the performance, it's there. It's got the goods. And this is the most exciting Wi-Fi access point that I've taken a look at that has multi-link operation, which is great. Love it. Let's take a closer look at the app. So you see what features you're going to get from the app and you get from management. And then we'll talk conclusion. So like all modern access points, these access points support creating multiple SSIDs, and multiple SSIDs can have multiple different radios configured, and you can configure the channel width and that sort of thing, because it's like maybe you want an 80 megahertz channel width, or maybe you want 160 megahertz channel width on 5G. You can do that. You can also exclude an access point from the mesh network, or you can choose to connect to an access point via 6 gigahertz for a backhaul, although I think wired PoE, wired connection is definitely recommended for all your access points. You do have a lot of options for each radio in terms of the channel, the target power, bit rate, but you can override individual access points. And that's kind of what I'm showing you here, but you wouldn't normally do it this way. You would actually configure it, at the network level, and then every access point you assign to that network will automatically inherit the settings, and they'll all be self-consistent. 5 and 6 gigahertz also support all the options that you would expect. You can set a minimum bit rate, so if something is using the 6 gigahertz band, but it's not at least 6 megabit, it's going to get kicked off. Remember, the range for 5 and 6 gigahertz generally is much lower than 2.4 gigahertz. There's also a lot of options for diagnostics, so you can hit clients and see a huge list of clients, potentially their SSIDs, a little bit of a history of their traffic and what all has, the different clients have done. For throughput and power status and clients, you can see some insights on the network and what sort of things are going on. It's like 71 gigabytes of upload from MSFT 5.0 from one of the wireless clients here. You get into a lot of fun stuff on your dashboard that Engenius makes available. All right, so bottom line, with the new firmware from the middle of June 2026, this thing is awesome. It's got much better device compatibility. It's got much better device compatibility on the 2.4 gigahertz side for things that, are ancient and only have a 2.4 gigahertz radio. And this thing has no problem keeping up with, 50, 60 clients across a whole genre of technologies. The 5 and 6 gigahertz support for newer devices is definitely very heavily weighted. Modern devices really have no business on 2.4 gigahertz, except that a lot of devices will use 2.4 gigahertz as like a power saving mode. 5 and 6 gigahertz radios tend to use more power, I think. And at least anecdotally, I've noticed that when a device is in low power mode, it seems to want to use 2.4 gigahertz for whatever reason. Doesn't really matter for a mini PC or your desktop computer, but it does for laptops and it does for other low power devices. Some, some Internet of Things devices, I mean, like I say, a lot of Internet of Things devices only have the 2.4 gigahertz radio, so not really a thing. But some people are trying to use wireless doorbell cameras and wireless security cameras, and putting all that stuff on 2.4 gigahertz is a recipe for disaster. And so stuff like this can better handle those things if you physically can't wire it. I'm Wireless Level 1. If you pick up one of these and you have experiences that you'd like to share, or just post pictures of how you hung them, let me know. And yeah, PoE 10 gigabit, you need a special power injector for that, because 10 gigabit. 10 gigabits, it's like Cat 6A, it's the whole other thing. I'm Wireless Level 1. It's been a quick look at the Engenius ECW536S Cloud 7. All right, if you have any questions or I miss anything, I'm signing out. I'll see you in the forum. You can engage below, ding, I don't know, algorithm, share, something. All right, I'll catch you later.